Hey everybody, this is Andy Melbuff, and this video is going to take a look at computational layer language and terminology for those who are just getting started with using CL and how Activity Builder is going to look at connecting things like sinks and components and sources all together. So let's go ahead and get started. So let's start out with some terminology. First of all, components. You're looking at a slide in Desmos Activity Builder in the edit mode, and on the left-hand side are what we call components. There's a note component, text input component, etc., etc. Each of these items have some specific feature when on a slide. Now, for this particular slide you're looking at, there's a note component, and below the note component is a math input component. Now, the note component is used for mainly conveying information or asking a question or giving out content to a student. So what I want to talk about next is the concept of a sink. A sink is something that we can use to inject values or amounts into a component. Now, this particular note component already says a sentence, sinks are a means for injecting values into a component. But I can go into the computation layer, and this is how I enter it right here, this icon. And I can put something into the background here. Content is an example of a sink. If content is a sink, it's colored green here, as you see, and it's followed by a colon. And this is a very simple example of a sink where we can simply type in quotation marks, what we want a student to see. For example, this particular content is going to be a question, what is the slope of y equals 3x minus 5. I should put a question mark in there. And when I click done and go to preview, I'll see that that is what shows up. The content from the computation layer overrides anything that's just typed in the front side of that note. You'll also see right below this is a math input box where we could get students to submit what we want them to submit to. So let me go ahead and exit this preview mode. And I also want to talk about the math input down here. The math input can also have sinks associated with it to inject values into its component. And I have one set up here already. It's called a correct sink. The correct sink basically says this is what's going to tell Activity Builder how to judge the student's response. Is it going to be correct or not correct? Well, the correct sink involves us identifying the component that we're going to judge. In this case, it's this specific component. We want to look for sorry, I didn't mean to drag that. We're going to look for a numeric value of 3 to be entered. So putting this all together here, Activity Builder will judge this as being correct if there's a numeric value of 3 that's entered. And the correct sink applies to the teacher dashboard. So let's see this in preview mode. Right here's the teacher dashboard preview. Nothing is indicated here yet. If a student types in the correct slope of 3, the teacher will see on their dashboard a check mark for the student here, meaning the student has successfully answered this question. If the student enters something incorrect, maybe they mistake the y-intercept for the slope, the teacher gets this particular feedback. And this only occurred because there's a correct sink that's put into this particular component. So there's an example of 2 sinks that are involved commonly in Desmos Activity Builder. A note component can have a content sink, and an input component could have a correct sink. Sinks can also connect components to other components. So we're looking at here a Numbersync, which we haven't really seen an example of yet, but you can see that it's green. And basically this says the number W is going to be connected to input 1 as a numeric value. So whatever a student might enter in input 1 numerically will be assigned to the number W. Now, when we connect sinks to other components, there's a little bit of a pattern as to how that works. So up here, a sink, if we connect to another component, the other component has to have a source, meaning what type of information do we want that component to provide. So on this screen, there are different sources, for example, for a Numbersync. So for this particular one that we just saw, the number W could come from input 1 as a numeric value. Or we could have a Numbersync T that comes from input 1, but as a timer. In other words, once the submit button is pressed, it initiates T as a timer starting from 0. We'll see an example of that. We could also have the number R be assigned to input 1, submit count as its source, meaning the number R is going to count how many times the submit button was pressed. So when we tie a sync to another component, we have to identify the source of information that we want that component to use. Different components have different syncs, and there are many of them available, and I'm just going to touch on some that I feel are the most commonly used ones, and the ones that I use the most frequently. So what you're looking at here in a note component, the two syncs I use most often are content sync, which we saw already, and the hidden sync, which we're going to see in just a moment. Now you'll notice next to the hidden sync is a little warning label, and that's because I haven't attached this sync to anything yet. So Desmos gave me a little warning when I screenshotted this. When I use a graph component, I have more options available. These are some commonly used syncs that I use with a graph component. When I use math input components, I have different syncs available here. And when I use text input components, again, we have different options available there. Again, some of these have warning signs because I haven't attached these to anything. I'm just showing you some common syncs that I use. If I choose a multiple choice component, there are a few. If I choose checkbox components, there are a few available there. Sketch components have these available syncs, and tables have these available syncs. So I'm going to jump out of this, and I'm going to go right back into Activity Builder. I'm in edit mode again, and I'm on slide number 2 here. And here's another common feature, especially, us math teachers, we like to connect different concepts and questions and extensions and things like that. So I've got a note here followed by an input here, a math input, but I've added a second note and a second math input. And that's because I might want to ask two related questions of students. So in our first note here, we're giving a student the linear equation y equals 3x minus 5. I might want to know what's the slope of the line, but I also might want to know what's the y-intercept for that same equation. Well, in preview mode, this is how it shows up. Here's my first note. I'm kind of hovering over right here. Here's my first input. Here's my second note. Here's my second input. But as a math teacher, I might want to stagger those, meaning I might want the second question to be held up until the first question is answered. So I can do that using Computation Layer and the hidden feature or the hidden sync. So I don't need to adjust anything on this opening note, but in my first input, I want to label it. I've already labeled this as input 2A. I'm using the number 2 because it's on slide 2, and I'm using letter A because there are two math inputs here. So if I needed to label the second one, I would call it input 2B. I'm going to add Computation Layer into my second note because I don't want this to show up until a student submits an answer down here. Now, what I've done is I put a little pound sign in here, which makes this a note and not active. I'm going to get rid of that pound sign, and you'll see this word show up in green, which means it's an active sync. It's called the hidden sync. And basically what this hidden sync is saying is, if input 2A has not been submitted and input 2A does not have a numeric value of 3, this component is going to remain hidden. The word not means both of those things inside of the parentheses have to be in play. Otherwise, this note is going to remain hidden. And I'm doing the same thing basically for this second math input. I'm going to get rid of my pound sign, which makes this active computation layer, and here's my hidden sink. So here's the condition inside the parentheses. I want two things to happen. Input 2a to be submitted, and I want input 2a to be a numeric value of 3. And if that's the case, if it's not both of those, this is going to remain hidden. So here's how we can inject some additional information into this component. Now, I'm going to click out of there and I'm going to go into preview so you can see how this actually looks. Here's my original note. Here's my original input. And the second note you don't see. It's hidden over here along with the second input. If a student types in an incorrect answer and presses submit, still this is remaining hidden because submitting was only one part of it. They had to submit the correct answer. If they submit a slope of 3, then you'll see the second question and the second input prompt show up here. So that's how we can use what we would call the hidden sink, tying it to two different conditions here in this particular component. As I mentioned a few moments ago, we may want to add Computational Layer to a graph component as well. So this particular slide, slide number 3, has a note on the upper right. It's got a math input below it. I've already identified or labeled that input as input 3, being on slide 3. And I've also included a graph. So what if I want this to be something of a interactive feedback type of situation for a student, or an interpretive feedback situation? And I want students to choose the slope of the line that's going to pass through these 2 points here. Well, if the student inputs a number in here for slope, can we have that be graphed over here? And the answer is yes. So I'm going to click into this graph component, and I've already put in the 2 points I want to use. I've checked the label box, and this is how that looks. I made them open circles here. But I also want to graph a line that will include what the student submits as a slope. So a general form of a line might look like y equals mx plus b. Now, if I type that in there, Desmos doesn't know how to interact with this because it doesn't know what m is, doesn't know what b is. I just want the student to submit one of these. I want them to submit the slope. So I'm going to give them the y-intercept, which is 3 in this case. So that cleans this up a little bit, but Desmos, again, can't graph this. M is undefined. What we're going to do is define M in the computation layer based on the student's feedback. So we'll come back here in just a moment. I'm going to click out of there, and I'm going to go into this computation layer, and I'm going to get rid of this note indicator. A number sync, in this case, we're assigning the number M to tie into the component input 3, and we want that component source to have a numeric value. And whatever the student types in for input 3, as long as it's a numeric value, it's going to get assigned to the number M. So we're defining the M that was missing in the component earlier over here in the computation layer. Well, let's see what happens if I go ahead and preview this. Now, if the student were to type in a number like 2, 2 is an incorrect slope, you'll see instantly a line pop up here. Well, we can get some good feedback from that. Clearly, the student can see it's wrong, but we can also add a few bells and whistles in here, and we can make this, this line graph in real time. So I'm going to exit the computation, or I'm going to exit the preview mode here, and I'm going to go back into my graph component, and I'm going to put a timer in here. And a timer is it's a super fun way that I've found to give students a little bit more involvement in the particular activity. So what I'm going to do is, using curly brackets, I'm going to put in a restriction, if you will. A timer is a domain restriction. I'm going to say that x is going to be less than t. Now, t is a new number that, again, is not defined right now. But I want you to see what t does. We already know that m is the slope, so I'm just going to add sliders for these so you can see what happens. Now, right now, you can see over here a line graph, but it stops. It stops at 1. And that's because when I inserted the sliders, t's value is 1. So what we're seeing is the line graph as long as the x values are less than 1. Watch what happens as I advance t from 1 to bigger. It's moving further to the right. So what we're doing is, by adjusting t, is we can have this line graph in real time for the students. But I need to define what t is. I'll do that in the computation layer, just like I did with m. So I'm going to get rid of this slider, and I'm also going to get rid of the m because I have the m defined also in computation layer. So clicking into the script here, I've already set this up in advance. The number t, and I'm using capital T for timer, and this is going to be, this number will be defined, and it's connected to input 3, just like the one above it was, but this time I want a different source. I don't want to know what the number is. I just want to know how long has it been since that has been submitted. It's going to start a timer. It's going to start the timer whenever the button is pressed, and it's going to run for 10 seconds. So let's see how this looks here as I hit preview. And a student might type in slope of 2. And you'll see, boom, instantly it comes in there. But again, that's not really that much better than what we had before. I want to see this gradually happen. So I'm going to exit this preview mode. And this just takes a little bit of getting familiar with this type of situation. I need to adjust this condition that I put here, this restriction, if you will. And so the way to do that is I want to start t not right at 0, but I want to back it up a little bit. I want to back it up by 10 seconds. And let's just go ahead and preview it, see how it looks. Student types in 2, and they press submit. Now you'll see right away that line doesn't show up because I started it back here left of where t was. And it's coming in slower, but it runs out of steam here because it's already run for 10 seconds. So not only do I have to start it further left, so I started it 10 units further left, I also have to speed it up. Here's how we can speed it up. We can add a coefficient in front here. I typically use the coefficient of 5. 5 will speed up that particular line as it's being graphed. So let's jump into preview mode. The student, I'll this time submit a correct slope of 1. The submit button goes, and here comes that in real time. And so this is how we can use the Numbersync twice using 2 different sources of information to impact a graph. So that's going to conclude my short introduction to language and terminology and talking about syncs and components and sources. Thanks, everyone.